When you take physics, one of the things you'll actually come across is a model for the height of a projectile, and we're going to use this equation h equals negative 16t squared plus vt plus h naught. And basically what's happening here is h, lowercase h, is the height of the object after t seconds. V is the initial velocity. And what that means is basically how fast are they going when they launch. Like think about a model rocket. It goes pretty fast, right? It's got a pretty fast initial velocity to it. But it's not fast enough for the rocket to go into space if it's a model rocket. It just goes up for a little bit and then it comes back down. Whereas if you have a big, really, really big, like, Elon Musk makes rockets now for NASA, they've got a very large um, initial velocity. They're really fast rockets. So when they take off, they go really high. And they go high enough to where the top of their graph is actually outer space. All right? So that's what initial velocity is all about. And the h0, that's just initial height. Oops, let me spell height correctly. So the idea is maybe you are a cliff jumper, someone who jumps off of really high cliffs, right? You could get a nice jump in the air, but then you go land way down where all the water is in the ocean, right? So your initial height changes the function because you started up higher. You might um, uh, not jump very high because you're a human and you can only jump, a couple feet, but because your initial height is so much higher than the ground or the water level, which should be zero height, you are in the air for a lot longer. So the initial height kind of adjusts things too. But those are the four variables that we're going to be looking for, or we're going to be given some information and then having to solve for another one. Example 4. Suppose a cheetah is pouncing on an antelope and leaps with an initial upward velocity of 19 feet per second. That's the v, right? Initial upward velocity of 19 feet per second. That tells me v is going to equal 19. How long is the cheetah in the air? So that, how long is the cheetah in the air? That is asking me, what's the time? If it lands on the antelope's hindquarters 3 feet from the ground. So what's interesting about this is when it lands, that's actually the h, the height. What's the initial velocity, the initial height? Well, it doesn't describe it, but imagine a cheetah running and it's jumping and it's landing on an antelope, right? Well, the idea is it's not jumping, it's not telling me it's jumping from a big cliff or a tree or something like that. It's jumping from the ground. So the initial height is 0, but the ending height is 3. It's 3 feet from the ground. Okay, so now I think we've got all the information we need. H equals negative 16t squared plus vt plus h naught. The height is 3 feet. The initial velocity is 19 feet per second. And the initial height is 0. So all we have to do is solve so that the quadratic equals 0 plus 19t minus 3. And now we try to solve this quadratic. And the only technique we have so far is to factor. So what I'm going to do is I'm going to look for the product of 16 and negative 3, and their sum should be 19. Go ahead and calculate that out real second. I'll be right back. Sorry about that. product of negative 16 and negative 3 is going to be positive 48, right? Positive 48. 3 times 10 is 30. 3 times 6 is 18. Yeah. So I'm going to look at all the factors of 48. That's 1 and 48, 2 and 24, 3 and 16, 4 and 12, doesn't go into 5, 6 and 8, and well, 7 squared is 49, so that doesn't work. So there's my options. I'm taking a look here. I spot with my little eye 3 and 16. Let's give that a check here. 3 and 16. 3 times 16 is 48. 3 plus 16 is 19. So it works. So this splits apart into negative 16 t squared plus 3t plus 16t minus 3. And all of that equals 0. Let's continue on with the factoring. Negative 16t, negative 3, 3t, and 16t. Now one thing, when I start this problem, if I notice that there is a negative in like diagonally across from each other, one of the rows I'm going to have to factor out a negative number from. It doesn't matter which one, I'm just going to factor out from one of them. I'm actually not going to factor it out from the first one. I want to factor out a 16t. Oh, this is supposed to be t squared, sorry. And what's left inside is I have a negative t and a 1. And then I'm going to check the second row, and I'm going to factor out this one. Since I didn't do it out of the other row, I am going to factor a negative out of this row. Let's factor out a negative 3. What's that leave me with? Negative 3 divided by negative 3 is 1. 3t divided by negative 3 is negative t. Check my columns, negative t and negative t. Yep. 1 and 1. Yep. So I have negative t plus 1. So I have 0 equals 16t minus 3 and negative t plus 1. Apply the zero product property. Each one of those binomials is set equal to 0. And we go ahead and solve. Add 3 to both sides. 16t equals 3. Divide both sides by 16. And we get t is equal to, oops, sorry. Oh, no, yeah. Is equal to 3/16. And now we go ahead and solve the other one. Subtract 1 from both sides. And I get negative t equals negative 1. Well, multiply both sides by, or divide both sides by negative 1. Multiply or divide, it doesn't matter. And t equals 1. So those are my two possible times. Now let's think about the situation again. A cheetah is jumping through the air and landing on an antelope. And we're wondering when it's going to land at the 3 feet of the antelope. But we've got two numbers, right? We have when time is 1 second, and we also have when time equals 3/16 of a second. Well, the first time, when it's jumping through the air, it starts at 0 feet, and it's jumping up. It hasn't reached the antelope yet, but I mean, it could be. Like, it could have jumped straight into the antelope and not had to come back down on it at all. So both of these answers here make sense. I mean, the antelope could have been standing over here in the beginning, or it could have been standing over here at the end of the jump. Doesn't matter, each spot is 3 feet off the ground. So our times 3/16 of a second, or time equals 1 second. Either one of those makes sense for the situation.